In Chapter 6, we are going to shift our focus away from triangles. We're mainly going to be focusing on quadrilaterals, but in Section 1, they have us focus on polygons in general. And within those polygons, we're specifically going to focus on their angles. So the first part that we're going to deal with is looking at the sum of the interior angles of a polygon. And in the second part, we will focus on the exterior angles of any polygon. So starting with interior, we're going to form what is called a diagonal, which is a segment that connects any two non-consecutive vertices. So for example, consecutive vertices would be like P and Q. So non-consecutive would be like P to R and P to S. Those would be considered diagonals. I can do this for any polygon, and what that really does is it splits my polygon up into triangles. So for example, this pentagon here, five-sided figure, I created two diagonals and split it into three triangles. We can do that with any shape. And then once I find the number of triangles, I can just take that times 180, because we know that any triangle adds up to 180 degrees. So a triangle, obviously we already know has 180 degrees. A quadrilateral we can split into two triangles times 180 would get us 360. The next one, pentagon, we just said could be split into three triangles. And then a hexagon we can split into four triangles. Hopefully you're starting to see a pattern within this. The number of triangles is 2 less than the number of sides. So to find the number of triangles, we would take our number of sides and subtract 2. And then to find the sum of the interior, this is the part that you're really going to want to write down. We're going to take n minus 2 times 180, which is what they do here. This is going to be your formula, if you want to say, of how to find the sum of all the interior angles of any polygon. Let's try some examples. Letter A wants us to find the sum of the measures of the interior angles of a convex heptagon. Anytime you see the word sum, that means all of them. And then you'll have to determine how many sides are in a heptagon. A heptagon has 7 sides. So we would take 7, subtract 2. This would get us 5 triangles times 180. Plug that all in. You're going to get 900 degrees for the sum of interior angles. For part B, they want us to determine what the value of each angle is in this case. So first, we're going to write an equation that deals with the sum of the interior angles. We already know that angle B and angle C are 90 degrees each. We need to find x so that we can find angle A and angle D. So first, I'm just going to take and I'm going to add up everything I know in this quadrilateral. I see a 3x and an x, that gets me 4x, plus I see 190 and a second 90, gets us 180, and that's going to equal some value. Since I know it's a quadrilateral, we know it can be split up into two triangles, or we can find the sum of the interior angles by using n minus 2 times 180, which would get us 360 degrees. So I'm going to set this equal to 360. We can solve this. Subtract 180, that's going to get us 180, and then divide by 4, that's going to get us 45. So for our angle measures, we know we can plug this in. So the measure of angle A, when I take 45 times 3, that's going to get us 135 degrees. The measure of angle B we already know is 90. The measure of angle C we already knew was 90. And then the measure of angle D was whatever x is, in this case 45 degrees.